So in today's session, I'm not going to talk about how you're going to be richer using Bitcoin. Instead, I'll be talking about how blockchain can be used to reinvent and revolutionize the way that businesses do the day-to-day workflows and businesses. So like Emma said, my name is Saffi Ali. I'm a cloud solution architect in a team called the Customer Success Unit. I'm part of a very special team within the customer success unit called the App Innovation. So we look after all of the application innovative idea. So when mostly customer want to modernize their estate, their application and their services. Let's get started with the session and talk a bit about blockchain, shall we? So before talking about blockchain as a technology, we just need to take a step back and talk about how businesses usually do the one-to-one or the business-to-business communication. And if you look at it, whatever business process that you will pick up, you would easily realize that trust is paramount for all of the parties involved into this particular business process, from the property market to the day-to-day supply chain that we rely all of us rely on to get our foods, our medicine, and even in the trade finance business processes. So if we pick one of those examples, like the supply chain. So even if we are, so in the UK, for example, if you look at bananas, bananas doesn't necessarily being grown in the UK. These are imported goods. So to get your bananas, for example, you can't imagine how many people that touch and benefit from you buying that banana. There is a lot of personas and a lot of intermediaries that sits between you and the bananas, the supply chain around it. And that supply chain would include the transportation, the financing, the actual inspection of them, and the storage of those bananas from the source and destination, and actually the inspection for the quality all the way around. So because of all of these personas involved into a single transaction or in a single business process, that would rely on a number of intermediaries and a lot of touch point between all of that. And all of those personas rely on trust. Trust is paramount between all of those parties, and intermediaries are there to make sure that you and me will get the best products or services from the source, and at the same time they need to oblige to a simple and straightforward requirement and regulatory requirement in the country. But not everything is as smooth as you might think. So today, businesses have two primary methods of establishing trust. They can either manually verify trust, or they can work with impartial third-party intermediaries to validate those kind of cross-party information. But both of these approaches present a significant problem because, first of all, the first problem that this will create is it will add friction by design. Friction would create slowdown of the transaction settlement until they can validate and verify it. Most of the time, these cross-party verification would involve human interaction, would involve people who sit in their computer and investigate these transactions, make sure that everything is aligned. And even if there is some sort of automation sits in between, they will still need to call somebody to kind of say, yeah, do you approve or do you reject that? The other problem that the verification with this validation, cross-party validation for this information is the increase of cost. By adding unnecessary steps and parties to process this kind of information often already complicate the process, who by nature the business process is complicated. And most of the time, and this is something most of the people who work on the supply chain knows, the business process in itself is straightforward, but the verification around it, it's the complex part, and that would complicate things. So blockchain, we are aiming, and the use of blockchain would make sure that these verifications are done automatically, but at the same time, it will establish the trust needed to make sure that those verifications are done at the right way. but it also would reduce cost because everybody in the network, like I will be talking about I'll be talking about that in just a moment, but that would reduce the cost, save the time that it takes to settle those kind of transactions, and obviously will lower the risk because the promise here is to make sure that these transactions are authentic and as per the required business process and business rules. Now, we already talked about the trust issue. Just to set the scene, let's talk about the blockchain as a technology. So blockchain, as it in its heart, it's basically a ledger. A ledger is like a table in a database or an Excel sheet. And basically data is stored in that ledger that would record this kind of transaction. This transaction could be someone is transferring £10 from his account to other people's accounts. It could be a transaction that represent a business flow of goods or service, whatever. But at the end of the day, it will be a transaction represented in a table. Right now, with that, you can represent this kind of information in a table, in a database or an Excel sheet. But there is another aspect of blockchain, which is the visibility of those transactions and the authenticity of this transaction. So in blockchain, everyone in the network will have an identical copy for each individual in the network, and that means if something changed, these changes will get propagated across the network, and everybody will see it. If something got altered, the same thing will happen. Everybody will see it. But again, up until this point, we still can represent that with a couple of hashes and even a distributed database like a Cosmos DB or something like that. We can have a multi-region database that everybody can access it. We make sure that everybody can have right authentication authorization in place to make sure that the data integrity in place. But up until now, blockchain is not unique. The uniqueness is in the third part. The uniqueness for blockchain is that anything that will get updated in blockchain has to go through the consensus algorithm, and that consensus will make sure that before you will be able to change, and that change could be create, could be update a record, nothing will these events or nothing of these actions will get propagated to the network without the agreement of all of the party or the majority of the parties in the network into the fact that this change can be accepted or can be rejected. It depends on what you want to do. And this is the key differentiator between in blockchain. So it's not as simple as going and put a record in a database. No, before you execute that, you have to come together and verify these transactions. And it depends on the consensus algorithm. Some of these consensus algorithm will be kind of a voting, where the majority of them, the majority will rule it, and could be, and this is called a proof of work. And there is another consensus algorithm called the proof of authority. But I'm not going to talk about the details of that. But you can think of anything that will need to be happen in a blockchain has to go through this consensus algorithm. And this is where blockchain would really add value and revolutionize a lot of the business process that we will be talking about in just a minute. Having said about having talked about the blockchain from a technical background, we can automate and represent workflows and business processes in blockchain. So we will represent the business rules into what is called as a smart contract. So there is no AI in that. Just I want to say that there's no AI when we are saying a smart contract. It's just a name that's been given. It's like it's coding or codifying the business processes into code, and that code would run into the blockchain. And because of the authenticity and the integrity of the data and the consensus algorithm that we have in the blockchain, we actually would drastically reduce the number of touch points and the number of intermediaries that sits between the buyer and a seller in the property market or in the retail. So if you look at the business cases that relies on trust, that actually fulfill one of these three things in the bottom of the slide, whether it's asset transfer, whether it's a cross-organization workflow or high assurance audit, there are hundreds and maybe thousands of business processes that actually falls in one of these buckets. and it's across industry. It's insurance, it's retail, whether it's in government, in health, and I will be talking about one or two of these use cases that actually runs in Azure at the moment, and where blockchain actually adds a particular value into that. But for now, think of a blockchain that it's a way to codify or is a way to execute your business processes to make sure that your trusted business process is governed by the business rule that you want to execute, but at the same time would reduce, or most of the time eliminate, intermediates, people who has to manually verify and manually approve things. Blockchain will make sure that the integrity of the data is by design is already approved and as per intended. So let's put this into perspective and talk one of the examples that runs on Azure at the moment in the Azure blockchain, which is the AB Moller-Maersk marine insurance platform. Just before talking about the technicalities of that use case, let's talk about the business problem that we are talking about here. So what if getting an insurance quote on your car would involve coordinating with not only your insurance company, but your council or your state department or the transportation body, the police, the local police, the state and federal regulatory agency? What if this insurance can change every time you cross one of the counties or one of the councils that you pass through? So if you drive your car in London, there's an insurance there. But if you drive this in Reading or any part of the UK, that's a completely different insurance policy. What if this is the case? Well, this is the case for marine insurance. It depends on a lot of different factors that would impact the premiums that the buyers and the sellers would need to pay to insure the goods. So Maersk is a global logistics company that most of the marine transportation has to go through them one way or another, and a lot of the containers that we rely to transport food, medicine, medical equipments, critical equipments, has to go through many. And most of the, I think 60 to 70% of the world trade is being transported via sea, and most of that is going through Maersk. And because some of those goods and services has to have a policy, an insurance policy attached to them, and because of that, there is a risk associated with where's the vessel right now in the sea. Are they taking the expected and the good and safe route? If there is any problem that they might face, like meteorological problem, like a hurricane or turbulence or anything like that, that would impact the security and the integrity of the vessel. How many years does the vessel crew that actually drive this vessel has been, in place? All of these factors would impact the insurance policy and the premium that those people have to pay. And because of that, they need to calculate that in near real time. And if you look at the number of insurance company, we're talking about hundreds and sometimes thousands of insurance companies that will be part of this kind of business process, and also the number of buyers and sellers and reinsurers. All of these different personas will be part of that. So you can, as I said, it's unbelievably hard to put manual system to actually approve or reject that, because some of those cases would involve a particular policy for each one of these containers. A single vessel can contain thousands, sometimes tens of thousands of those containers, and each one of them could have its own policy. And because of that, that would require a kind of a near real time to process it and process and propagate these data across all of these parties. So the idea here is, and this is an oversimplification of one of the business processes that we are talking about, but the real-time maritime risk assessment would be like this. Before the vessel, before the ship would leave the port of departure, there will be an ideal path attached to this vessel. on the system. So basically, in order for this vessel to go from, let's say, South Africa or Brazil to the UK, this is the specific path that this vessel has to take based on certain risks, and this is governed by the Maersk Central Logistics team. But because the transportation would take sometimes weeks and could be months, there are a lot of things that could change the ideal path to be a less ideal path. That could be, as I said before, could be a meteorological problem, could be a piracy risks. All of these things happen in near real time. But because of this maneuvering requirement, that could increase the risk on the vessel. So there is an imminent risk if they took the ideal path. No, for sure, there is a hurricane in the ideal path or something emerged, but there is a less risk if they go to the danger zone. Because of this changed risk, there have to be a reassessment of the risk, and that would impact the insurance policy. And as you can see on the screen here, once the ship deviate from the ideal path, that would automatically trigger a reassessment of the risk, and that would evaluate the premium that the insurers would require from buyer or a seller or a reinsurer. And all of these settlements will happen in near real time. And as you can see here, we are not solving only the near real time, because we can do that with an IoT, but also, and this is more important, we are using blockchain here because the number of people that involve in this transaction, involve in this business process, and there is no trust or minimal trust between all of those parties. The insurance doesn't necessarily trust fully Maersk or its data. And also someone can say, well, this is Maersk data. We have no access to this data. Maybe you've manipulated that data. But with blockchain, everybody is part of this network. Everybody can see this data in near time. Everybody can see the IoT data, which would include the longitude, the latitude, the risk parameters like the movement of the ship itself. All of that will be visible to everybody. And when I say everybody, yes, there are certain controls that can put in place, which depends on what blockchain that we are using here. But the fundamental idea here is the data will be shared across of them, and nobody will be able to change anything without the consensus of everybody. So this is one thing. This is one example. There is another example with 3M. 3M is as you all of know, that the 3M produce everything from pharmaceutical equipment to the DIY stuff. So in this particular example, they had in 2018, they had a program called Label as a Service. So basically, 3M the 3M Label and Materials, they have over a portfolio of 55,000 products in its portfolio. So the research group started to explore how they can digitize this whole supply chain of those things with a service called Label as a Service. And they turned to the blockchain on Azure to explore how they're going to have this shared data layer among all of the parties as part of this supply chain, so they can have end-to-end visibility of where those materials came from, when they were received by the factory, how they have been processed, how long it took them to actually do the end-to-end processing, and when they actually reached the retail store, when those products and those materials had been bought. And we are talking about the pharmaceutical equipment and sometimes drugs. It's really important for them to know that there is no counterfeit happen, and this is actually to battle the counterfeit of the pharmaceutical authenticity from end to end from the supply chain. So this is the flow. So as you can see, this is the journey from top right corner. So if I use my marker in here, this guy, sorry. So basically on the top left, so all of those drugs originate from the manufacturing, factory itself, and there is certain drug. So let's say there is a certain drug that this is being produced by this factory. They will hook that as part of the prescription processor. That prescription process could be a single pharmaceutical company or a chain of them, could be a hospital, could be the government body. They will connect both of these people together as part of the chain, and they will have all of these labels. So once the drug left the manufacturer, this label will be entered in the blockchain. And once the prescription processor, so you can think of it, as I said, as a hospital. So the hospital will scan that QR code, would make sure that this comes from one of those provided and identified suppliers and producers. Then this will get carried by the carrier company or the logistics company. This will get taken and processed again and confirm the receipt of it. This will then get stored in a warehouse, and all of these things between the carrier and the other carrier, each one of them will handle by just scanning the QR code of those boxes. And in the retail store, as a patient or as a dispenser, you would be able to scan this and make sure that this is actually an authentic product or authentic drug. And this end-to-end journey will make sure that, first of all, no counterfeit products will enter the supply chain. This is a straightforward benefit from a business perspective, but ultimately there is a big benefit when it comes to the safety of the patients themselves, to make sure that those are the authentic products and authentic drugs that they've intended to buy, and they came from the authentic source. So these are just two examples of how blockchain can be used, and I just picked up just these two. We can continue to talk about another 2 or 3 of them, but let's talk about the technicalities of how these solutions can be implemented in Azure. So I think I can pause for now, just to give it like a minute or two to see if there's any questions before we talk about the technical stuff, if that's okay. So if you have any question, feel free to go to the chat and pop it up in there, and I'm more than happy to answer those questions in the meantime. Yes, can you, I think, yes, can you access the slides after the presentation? Yeah, I think Emma already answered that. Just in the scenario, many a time transporters are turned off by vessels to evade sanction, but can use genuine reasons. Let me just try to digest this question. So many a time transporters are turned off by vessels to evade sanction, but also genuine responder. How does it impact the scenario? Well, in this scenario, everything. So if we in this particular scenario, obviously I can't talk about the details of how this has been implemented. But the fundamental idea is that this will be like an IoT-enabled, not only vessel, IoT-enabled containers. So all of this will get transported. If someone evades something, it's not the vessel, it's the container. So the container itself will get tracked in near real time. Over the satellite, over the normal network, over the internet, all of that will get transported to the ledger, and it continuously sending the longitude and latitude, and they have the topological map that would include the risks into certain areas. So if the vessel or the container enter one of those risks, that would re-evaluate the whole thing, that would re-evaluate the business process. So no matter what you are trying to do, there is a continuous feeding of the location of this vessel and the container, and even the movement of the container. I will be talking. So there's another question called, what is the technology behind 3M and Maersk? So this is the second part of the presentation, will be technical stuff. Is the issue most scenario trust and accountability? Yes, this is the fundamental thing. We are not really want to use blockchain unless we have a trust issue that we want to mitigate, and also the manual verification of certain aspects that because of the lack of trust. So blockchain can solve the trust issue, but fundamentally it will also solve the problem related to the manual verification that is required by multiple parties into a single source of truth. Will the QR code change along the way? No, it won't. It won't. It will be the same QR code. Once it left the house, this QR code will get attached to the container or the box that has this, and each one of those bottles. So if I don't want to give away much details, but let's say that this is a single bottle of drug, and that bottle of drug, there is a QR code in it that says this bottle came from this source. So as part of the scanning or the dispensing, there will be a scan of that QR code. If that QR code is not recognized, and when I say recognized, it will try to match the QR code against the central database or the ledger itself that knows about that. If it doesn't know about it about this, that means it's not the drug that can be dispensed. So the multi-layer QR code, this is the idea of having a central QR code from the manufacturer to the dispenser, to the prescription. This is one layer, but also there is another layer between the patient and the prescription dispenser. So there is a prescription processing, which is basically making sure that those drugs are already in stock, already in place, and they can produce them. This is the first part. This is the first leg. There is another leg related to that QR code. Make sure that this particular drug can be dispensed to this patient at that time. So this is called a multi-layer, and they needed to kind of disconnect this. But this is for 3M. It doesn't necessarily reflect that this is happening all over the world. Yeah, keep those questions coming, guys. I shall focus on the switch to the technical stuff in how these things can be implemented in Azure. So if I switch back to the following slide, which is how we're going to build blockchain. So unfortunately, building blockchain network is not easy. Let's put it this way, because you have to think about right now, when we are talking about blockchain, we have hundreds of different flavors of blockchain ledgers, whether this is Ethereum, Hyperledger Fabric, Coda, and more, and different flavors between the two. And because of that, to be able to build a single node, there's a lot of infrastructure work needed. You need to to have the infrastructure that would run that, a couple of VMs, a couple of virtual machines or physical machines that would run the operating system that would host the ledger itself. And once you do that, you need to enable the network. So obviously blockchain will involve multi-party and multi personas as part of that network. So that means you have to make sure that the network is secured. You have to put the right guardrails when it comes to authentication authorization. And then you will be in a position to write your business logic. You will be in a position to manage the health of those nodes, and then at last you will be able to write your smart contract and start to test the process. So because of that, we at Microsoft have we started one of the earliest hyperscalers to invest heavily in the blockchain space. We have like a multi-stage way of thinking about how you're gonna build your blockchain. We started by discussing the bottom up. We have the network, how you can launch and manage the network. So to make things and make life easier for developers, for enterprises to start their blockchain implementation, whether this implementation aimed for production or even just to prove that this business process can be represented in blockchain or not, we started by investing into a new service called the Azure Blockchain Service, which is a fully managed service. That means that it's a platform as a service, which means that you just don't need to worry about the infrastructure that we run behind the scenes to your network. You just go to the Azure portal, you say, I need a blockchain service. You will get the service and you can scale it out across multiple nodes. You can add number of nodes, you can manage, deploy them, manage the network topology, manage the authentication, authorization. All of that has been implemented for you. So all we need to do is just you just say, I need this network of, let's say 3 nodes. I need, this is the size of the computation that I require. And you can scale that up or scale that down. So this is the fundamental, this is the kind of the cornerstone of any blockchain network. So we've solved that by the fully managed Azure Blockchain Service. But then there is the whole end-to-end authoring for developers. So how your developer will be able to develop smart contracts. So developing smart contracts is not really like building a C# application or a JavaScript. Despite the fact, if you are talking about the Quorum blockchain, for example, you would write essentially similar to a JavaScript. So Quorum or Ethereum generally. And the problem here is to be able to deploy, to create. There are dozens of those tools that we can that is needed to actually create the smart contract. One of them is a tool called Ganache, which is a test network that you have to have in your development environment in order for you to test the code. There is the tool that would enable you to deploy that to the network, and this is another tool. There is the IDE needed to develop those things. And we actually encapsulated all of that for you into a single plugin in Visual Studio Code, and I will show that in a minute, called the Azure Blockchain Development Kit, which is basically a single download. You just download all of the prerequisites and you will be ready to go to create your first blockchain application. You don't have to worry about downloading different things, disconnecting things, different commands for different tools. You just download that, and right now we are supporting Ethereum, and there are a lot of them coming to support different ledgers. The third thing is blockchain on its own is useless unless you will be able to integrate that with external system. And the scenarios that we just talked about, we are talking about blockchain is just a central database that ingests data or respond to event that happens outside of its boundary. And because of that, you need to connect to the external world. You need to ingest IoT data. You need to send information about events happened in the blockchain because of the change of the longitude and latitude. So for example, in the Maersk example, so once the vessel deviates from the ideal path, this is a data ingested that would trigger a specific code that exists in the smart contract, and that would trigger certain calculation, and that calculation needs to be propagated to an external system to say, this is the risk, we need to send that to the CRM or the risk assessment tool. So all of these kind of integration, it's not easy, and everything in blockchain is sealed. So we've built the heavy lifting around that, and we've built two things. The first one is a service called the Azure Blockchain Workbench. And the Workbench is like a prototyping. It's like a solution enabler. It's a solution accelerator where you say that I need like a SaaS solution. It's like a SaaS. It's not fully a SaaS solution. It's not a SaaS solution. It's like a solution accelerator where you just upload your smart contract and one configuration file, and you have everything in place. You don't have to do the integration. You don't have to worry about how you're gonna add this authentication layer, how you're gonna store those keys, how you're gonna do the integration between your smart contract and the external one. We did the heavy lifting for you, so all you need to do is just send this information, and I'll show that in a minute. The second part of the build and extend pillar is the dev kit. On GitHub, there is the Azure Blockchain dev kit, and I will send you that in just a minute. I'll send you a link for that. So this is like what it says in the tin, basically. It's a development kit with a sample code and sample deployments, even with sample smart contracts that would enable the developers and accelerate the developers' discovery of certain scenarios or certain integration scenarios. So with that end-to-end picture, you have the infrastructure that is needed to run the blockchain. You have the tools that would enable developers to accelerate things up faster, and you have the accelerator solution on top of all of that that would enable both developers and the business decision maker to develop, monitor, and realize the value of the blockchain solution. So as I said, just to go quickly on the details. So Azure Blockchain Service currently in preview. It's a managed blockchain network. With a few clicks, within 5 to 10 minutes, you will have this network, and all of the network management will take care of that. You can govern. So mostly in a blockchain scenario, you have this idea of a consortium or a consortia. The consortium is the kind of the governing body on top of all of these different personas. So you can govern who can do what and when, who can see this data, who can't. So Azure Blockchain Service right now supports Quorum, and we have a plan to support different ledgers at the moment, as I said. So right now, Quorum, and we have a plan to expand to different ledgers. So Quorum right now support, I think we're up to 2.5 right now. And we support the IPFT consensus algorithm and Tessera as a transaction manager. So if you are familiar with Quorum, these are the limitations when it comes to what level. So, but the idea here is we have like an N-1. So the version has to be tested first before we be able to release that into the managed service. It's a highly scalable, highly patched. You don't have to worry about upgrading and moving and patching the servers. We will patch them for you. You don't have to worry about that. Native integrating from the Azure Monitor to monitor the logs, the errors, the transaction. You can use log analytics to monitor the error logs that can be generated. And obviously out of the box, there is the utilization that comes outside of that. So right now, in terms of how you're going to manage the ledger, it is supported by PowerShell. But once the service will come GA, you will be able to manage that as part of the Azure portal natively to administrate that. So shall we do a demo end-to-end of what we have into the Azure portal? So what I'm going to show you now is basically this. So we have this end-to-end architecture of what I'm about to show you. So basically, in the example that I'll be showing you that in a minute, is the Azure Blockchain Workbench. So you will have the Azure Blockchain service as the back-end service for the blockchain. But as you can see here, the service on its own is just a single service, but you rely on different things. You are relying on how you're going to ingest IoT data, how you're going to do this transaction, because once you ingest this IoT data, you might need to do some mapping, some validation before you send that information to the blockchain, and the blockchain will trigger the validation or the smart contract execution, and that would trigger certain integration layer, which is as part of the read and write. But you can think of this architecture end to end. But the good thing about this end to end architecture is you can see the number of integration points that you would need to be able to interact with blockchain. So without further ado, I need to switch to the, if I just keep showing, if I switch to the other screen, just to show you what we have. Right. So if you go to the Azure portal right now, portal.azure.com, just hit new. Just hit here. And you can see here there's a complete section called blockchain. And the first two services is the Azure Blockchain Service and the Azure Blockchain Workbench. So the Azure Blockchain Service uses the Azure Blockchain Service as the backend blockchain service that it relies on when it comes to how you're going to integrate that with. So I've already done that. I've already created an Azure Blockchain Workbench. But let's go through the authoring process of that. So if I click on that, let's create an Azure Blockchain Workbench. So the first thing is the subscription. What's the resource group name, the location, the resource prefix, and if I go to the advanced settings, you can see here, do you want to create a new network or do you want to use existing? I already got my existing network and I've already used my existing network. But if you, let's say that you have multiple Azure Blockchain services in place and you need to use multiple blockchain workbench instances for different scenarios, you can still do that by using existing network. And these are the service tiers. You have the basic. For the preview, we have basic and standard. And at the moment, it's just a limitation into the compute power and the number of nodes that you can add to the network. And the last option here is, or the last parameter that you need to provide is the working node. And this is just the size of the VMs. And right now, this is the kind of the supported ones when it comes to blockchain. And this is the number of cores, the number of RAM. You can support up to 30 gigs for a single VM, by the way. Or a single node for. I already created that, and if I go to my Azure subscription, if I go to the resource group, if I filter that, I just show a blockchain PC. And let's have a look at this. So we have this RGPC web. So once you deploy the Azure Blockchain Workbench, you can see there's a lot of after successful deployment, of course. And one thing I need to highlight here, once you fill in everything for the Azure Blockchain Workbench, it can take anything between 10 to 20 minutes to deploy. So you just fill in the information and just leave it. And after 10 to 20 minutes, you will have all of these resources. And as you can see here, there are a lot in here. There are a lot of resources. We have a database, we have an event grid, and we have a couple of websites and app services. We have a storage account, we have a test availability test, etc. And obviously, I have a SQL database. So the important service or the important resource that we need to visit is this guy, is the app service. There is this, whatever prefix that I added, and there is the suffix, which is then auto-generated number. This is the portal for the Azure Blockchain Workbench. So if I click on that one and just click on that website, this is the website, and this is the Azure Blockchain Workbench portal. So as you can see here, it's just like a simple website, but the simple website would enable you to just do the following. The first thing that this Workbench would enable you to do is just create a new application, create a new Blockchain Workbench application. So what you need to do now is basically create the smart contract. So basically you write your smart contract and another file called the configuration file. So if I show you what those files look like. So right now, so this example, we are talking about the refrigerated transportation. So we are transporting, let's say bananas or sensitive things that has to be refrigerated all the way from source to destination. So the first thing is the smart contract. And this is the Solidity smart contract for Ethereum and for Quorum. So basically, this is the programming language called Solidity. Solidity is how you write. As you can see, it looks like a TypeScript type of implementation. And as you can see here is in this smart contract, what we have is the business process that will govern a refrigerated transportation, the journey from source to destination. The first thing we are defining here is a kind of a list of property, like the different personas. So obviously we have an owner, we have the counterparty, the initiating counterparty. We have the device, the IoT device that will send the temperature and the humidity from the boxes or the containers. And we have the constructor that will initialize all of these variables. And we have a list of methods in here that will get executed that will govern the business process. So the business process is quite simple. If the humidity and temperature exceed a certain threshold, invalidate the transaction and send the information to everybody in the network. And that's exactly what we are doing. So the first thing we are doing is ingest telemetry. So we are accepting humidity, temperature, and the timestamp, which basically the device will send continuously. And as you can see here, else if. So basically, if the temperature is more than the maximum temperature or the temperature is wrong, go to temperature and make sure that temperature is out of range. And you see here, we are setting the compliance status as out of compliance. And this is exactly what we are doing when we are talking about the complete. If the status is out of compliance, revert and send the information about the status. So this is the first thing. This is the typical thing that you need to do. But the extra thing that you need to provide here is how the Azure Blockchain Workbench will assign users from Active Directory to the Azure Blockchain Workbench itself. So for example here, and this is just the configuration code that you need to add. So right now I have a single workflow called the refrigerator transportation. These are the property, single property, and we have a well-documented documentation that will describe each one of those nodes. But the important thing that you have to add here is the application role. The application roles is how the Azure Blockchain Workbench will add roles to a specific users in your Active Directory. So how this will work. So basically what I have now, what I need to upload now, the first thing is the JSON file, the transportation JSON, and it would automatically validate that whether this is a right application or not. So let me open another one, which is this is with time, and let's upload the Solidity contract for it, and I just need to hit deploy. And as you can see here, we have this guy. So this is an application now called refrigerated transportation, I already done this before, so I just need to click on that. So you see here, this is the beauty of how Azure Blockchain Workbench will save you a lot of time and a lot of money to integrate blockchain with Active Directory, for example, to authenticate and authorize. So right now, if I need to add member, these are the rules. So remember this list of application rules. This will get propagated into blockchain Workbench itself. So these are the rules that will get understood, and this is the metadata for them. So as you can see here, I can search for myself, and this is automatically querying my Active Directory. Your Active Directory, you need to provide that as part of your provisioning time. You need to look at which Active Directory that you need to look at while you are doing that. So as you can see here, it can query my Active Directory with the list of users that I have. So I have different users. I can add or remove them, but I already did that. I already have myself and admin as a user, as an initiating party, and as a device. So what I need to do now, because I logged in as my Microsoft account, I have saffi@microsoft.com. But what I need to do now here is this, is to take this guy and let me enter the password for it. Okay. So let me copy this. Let me copy and go here. Let me copy. Right. And if I put this one in here, let's create a new smart contract. So when we are creating a new smart contract, you can think about from a business perspective, this is just a journey that would describe that, where is the device that will send the telemetry? Who is the owner of this, journey? We are transporting certain goods from one location to another. And what is the mix? Who is the observer? So what I will need to do is just add myself as everything. So let me add myself here, device. This is the device. I add myself as an owner. I add this observer as an admin. And I would say the maximum humidity would be 50 and the max humidity would be 60. And minimum temperature is 2 and maximum temperature is 5. As if we are transporting, vegetables or fruits. This is like the things that need to be monitored. So I need to create a new smart contract. So within seconds, I actually created this journey. So now we have a smart contract that will get monitored by the blockchain. So how can I ingest data from the external world to the blockchain? So it's easy with the Azure Blockchain Workbench. So I need to switch to another thing here, which is Logic App. So if you remember, when you look at the resource group, one of the resource group that will get created is a service bus namespace. So for you who don't know what service bus is, it's a messaging service that would enable you to create queues and topics for publish subscribe based architecture. So what this will do, basically, we have few queues in here that can accept message. And one of the interesting queues that we have here as part of the Azure Blockchain Workbench is something called Ingress queue. So with this queue, I can send messages from the IoT devices to the Ingress queue and make sure that those messages will get processed by just the metadata, which is exactly what I did here. So I created the Logic app, and if I just show you in just a minute, in this Logic app, I have a rule that says when a rule is fired. So I'm using another service called the IoT Central. So remember, we are saying that we need to rely on IoT devices. I don't have a hardware device at the moment to send this information, so I'm relying on another service called the Azure IoT Central. So within the IoT Central, you can create real devices or simulated devices. So I created a simulated device here that would send humidity and temperature to whatever endpoint that I want to send it. So basically what we have here, if I go to the device templates, if I go to the refrigerator transportation, if I edit that one, and as you can see here, the humidity is 10 and the maximum value is 100, and the temperature is, let me edit that one, it's 2 and 5. But if I enter that one, if let's say it's not 10, and remember the smart contract was saying 2 to 5, but I'm now exceeding that. So let's say the minimum would be 5 and the maximum would be 10. So that means if I go to the blockchain, and let me go here and save that. Before saving that, I just need to show you the runs of that. You can see here the last runtime was 17.7 for something, which is today. And if I, sorry, it's not today, I just need to trigger that value and send it over to here. So the data will start to pick up, will start to increase. This is the value. And if I go here, this is the humidity, started to increase. So that means if I go to the IoT Central, if I refresh that, go to the measurement again. Let's go 50 and let's save. And hit refresh. And you can see here, there's a message, 20 of July. If I click on that, there's a message has been sent to the blockchain right now. So once the information came from the IoT device, there is a few things that we are doing here. We are calling a SQL server to get the data about which smart contract that we need to validate, but all of that is documented and it's into the details. But the fundamental point here is that we are sending this information to the smart contract, so the smart contract can validate or invalidate that kind of information. So if I go back to here, you see, it was started, but now it became out of compliance. So if I expand this here, it said the activity, first activity is that I recorded an action, and then the device, which is recorded under my Microsoft credential, recorded against ingest telemetry. And this telemetry was, if I scroll down, humidity was 50, the maximum was 60, and this is the 2 to 5, but the actual value was 65. See, it is invalidated because my range was between 50 to 60, but the sensor data was 65. And as you can see here, I didn't do much to be able to create this end-to-end story, all of them.